Alright, so we're going to geek out with electronics. And I need a flasher circuit for the Excelsior. Just a single circuit for the strobes. And there's an integrated circuit, an IC as they call it, Silicon Valley. This is old as dirt. It's a 555 chip. And this particular one is Texas Instruments. Let me show a close-up. You can see the actual writing on it. And it's a pretty simple 8-pin integrated circuit. And it has properties. It can be run in different modes depending on how you deal with it. In this application, if you want to look up on Google, it's called asynchronous 555. And you can Google timing calculator 555 on Google, and you'll see this chip brought up, and you'll see three values. One of them is resistor 1, resistor 2, and then capacitor. So I've plugged this chip into a breadboard here, and if you're not familiar with a breadboard, this is a way to test stuff before you actually commit to soldering. And so right now the chip is sitting in the middle here, and each of the legs is plugged into one of these little slots, and each of the slots is bused outward in this direction. So you can plug in as many things as you want connected to that bus as you want. And then on the outside edges, this whole line right here with the red is bused together, and that I connect to a lead over here to where that's positive power, in this case 9 volts. And at the bottom here, this is your negative side, 9 volts. So that's a way to plug stuff in and play with it and test it. And yeah, maybe you burn it up, but the fact of the matter is you burned it up, but it's before you committed to actually soldering it all together. So in this case, this is the circuit diagram for this 555 strobing circuit. And if you want this, I can send you a copy. It's just me scratching out what I want. But just email me, scott@modelerx.com, or send me a comment in the text below, the comments below. But the three pieces of information that we need, if you look up one of these calculators, are resistor 1, resistor 2, and then the capacitor. And we'll start with the capacitor because that's easy. It's not going to change. It's 10 UF, and so there it is right there. And then I take it back. There's actually 3 resistors, but 2 apply to the circuit board, and 1 is strictly for the LED, which we always use resistors for LEDs, and in fact it's the same kind, so don't worry about that. But the 2 resistors we're talking about here are R1 and R2, which one of them is 120K, and the other one is 5.6K. So, given what we've got drawn up here, which is what I did, we're going to wire this breadboard up exactly like this drawing. So the first thing, and I just usually go counterclockwise starting with pin number 1, and there's a notch on this side of the circuit board, and if you have that facing to the left, then your first pin is the lower left one, and then in a counterclockwise way they number sequentially, so it's number 1, 2, 3, 4, and then jump up here 5, 6, 7, 8. There's our 8 pins, which corresponds to this diagram. So the first thing to do is pin 1 needs to go to negative. So I'm just going to put a little wire in here. As you can see, just connected pin 1 to negative. Pin number 2 has 2 connections. The first one is it needs to connect to pin number 6. So I'm going to connect another wire here from pin 2 to pin 6. The other thing connected to pin 2 is the capacitor. And capacitors are polar, just like a like an LED, which means that they're positive and negative, and it does make a difference, unlike resistors. The way you can tell, and this is a radial resistor, which means that both of the leads come out of the bottom of it. Some of them, there's one that comes out of one end and one comes out the other end, and some they're disc shaped and they come out the bottom, but this is a radial resistor. And so if you look on the housing of the resistor, there's a black stripe, which is right there, and that indicates the negative lead with some arrows going down. And in this case, it's the shorter lead, which is just like an LED. So this is our negative one, and the negative part of the resistor needs to go to negative power, and the positive end connects to lead number 2 on the IC, on the 555 unit. So there we go there. Pin number 3 I'm going to skip for now because that's our output to the LED, and I'll deal with that right at the very end. Pin number 4 just needs to connect to pin number 8. Kind of like 2 connected to 6, this one goes to 8. So that's going up over there. And then pin number 5 has absolutely nothing going on, so happy pin. Pin number 6 and 7 and 8 is where we get into our resistors. So I'm going to start with the connection between 8 and 7, which is our resistor number 1. In this case, it's 120K resistor. And in this case, it's, if you go from the gold band upward, it's yellow, red, brown. And so I'm going to connect that from pin number 8 to pin number 7. You got to kind of fold these little babies over and sort of bend them out of the way so they don't touch each other. It's one of the things you just got to worry about. You don't want resistor legs touching each other when you're doing this. And now we're, so that was 8 and 7, and now we're going to go from 7 to 6, which is resistor number 2, which this is our 5.6, which if you look at it, starting with the gold band, it's red, blue, green. And I'm cheating up here. This is a resistor chart which shows you what all the colors are and what all the resistors do. And so now we're going to connect this from pin number 7 to pin number 6. So we'll boom that over there. So now we've got 3 wires, 1 capacitor, 2 resistors connected to this board. And the one last thing is we need to connect pin 8 right up here. We need to connect that to positive power. So let's punch that in and punch that in. Alright, so kind of observe this and make sure that none of the leads are touching each other. And then our last pin, which I didn't do earlier, was pin number 3. And this is where we start playing with an LED. So here's just a green 5mm LED. I'm going to bridge it over this gap just like I did with the IC. I'm going to put negative towards the bottom and positive towards the top. And when we're talking about the resistor for the LED specifically, this is just a typical 470 ohm resistor which came with the LED. We're going to connect that from the positive lead of the LED to positive power. So if you can see that, that's what we got going there. And then the last connection is the mystical pin number 3, which is, that's the output of this whole chip. This is the thing doing the job. We're going to connect pin number 3 to the negative side of the LED. And so that's what's going to drive the blinking. So you can look at that. And there's the paper version. So now we have our positive and negatives going off the side here. Let's get some 9 volts over here, and we'll connect 9 volts positive to 9 volts negative. And voila, we have a strobing light. So now that we got that going, we can play with it. If we want to diminish the brightness, just adjust the strength of the LED the strength of the resistor that's on this LED. So pump that up. Instead of a 470, I don't know, put a 2.2K, put a 5K, put a 10K, and this will limit the amount of brightness that this LED has. One of the cool things about this timer circuit, which it took me a while to figure this out, is that it's kind of lopsided in terms of the ratios. If you use that online tool, you'll find that the amount of time on is a lot longer than the amount of time off. But there's a way to manipulate that. In fact, that's what this circuit has already done, is that it's manipulated, it sort of flipped the time on and time off. And let me demonstrate that. It's almost like in Spaceballs where Mega Maid went from blow to suck. That's what this is. So if we unplug this right here and we flip this around, so we're going to have the resistor feed the positive end of the LED and then plant the LED's negative side into the negative socket. You can see we've gone from suck to blow, where the majority of the time for the LED is on and then it just flicks off real quick, as opposed to the strobe effect, which was this one, where we put the resistor on the positive side going up here, move the positive end to touch the resistor up here, and then the number 3 area on the chip feeds the negative end of the resistor of the LED. Now we've completely changed this circuit to where it's off most of the time and it's on very little of the time. So like I said, the suck to blow effect. Alright, so now we got this going on and everything's cool, and the next step is to sort of solder this whole thing into a board to put inside of the ship. And we took the same components and using some of this little board like this, I'm sure you've seen this before, you can order this online and in all sorts of sizes and varieties, and I've just been kind of chunking away at this. But the most recent project was this one, and you can see the 555 chip mounted there. There's the capacitor, and then real close on those two ends, there's the 2 resistors. There's 3 leads coming out of here, which is your positive and negative power. And then pin number 3, the magic pin, I've put a blue wire on here, and that's going to drive the negative side of LEDs, which then I just connect the positive lead to power with the resistor, and everything should work. So let's disconnect this, and to demonstrate multiple LEDs, which the Excelsior here has 5 independent, or they're not independent, they're coordinated LEDs, 2 at the end of the nacelles, 1 in the middle here, 1 in the belly right there, and then 1 at the top of the bridge. And so this board right here represents, there's 5 green LEDs and 5 470 ohm resistors. And so after we wired this whole thing up, we're going to take positive power to power the board, negative power to power the board, and then we're going to take one more. We need to do positive power to all these LEDs, so I'm just going to connect this to right there and connect that This is the same sort of deal. It's a breadboard. Doesn't have the red going along the whole way, but this whole bus here is positive, 9 volts. And we're going to connect this right here to positive power for the LEDs. Set that over there. And then our number 3 pin, which is represented in this case by the blue wire, that needs to go to the negative end of all the LEDs, which, looking right here, all the negative end of the LEDs is all plugged in to this bus right here. So all I'm going to do is plug this in to the negative bus. Oops, the wire kind of crimped and creaked there. Let me try to get this in there. And I just can't get that to go into the socket because this wire wrapping wire is so thin. There we go. No. Alright, there we go. So, now we have 5 LEDs flashing in our strobe effect. So when we get inside the model, we simply mount this, apply power, and then take this number 3 lead and connect it to the negative side of all 5 of the LEDs that need to flash. 1, 2, 3, underbelly 4, top of the saucer 5. Take the negative leads and clamp them onto this baby, and then connect the positive lead to basically model power positive 9 volts with the resistor, and then everybody's happy and we get flashing. The cool part about this is the components. Like I said, the 555 chip is pretty inexpensive, and resistors and capacitors are, geez, a dime a dozen. So if you got a little patience and can play with the circuit, and yeah, there's ups and downs. Sometimes you screw it up and you burn up a chip, but you know, you start over. But the fact of the matter is, I thought this was pretty cool. And you know, these 555 chips, look it up on Google, they're everywhere. And who knows where, and boy, those are bright. But anyways, there you go. Sorry we geeked out. I know this is probably longer than everybody expected. God, geez, we're 20 minutes or longer. So, geez, it's almost 30 minutes. So anyways, hope that helped. And if you have any questions, leave it in comments or email me, scott@modelerx.com. Modeler spelled with 1 L. And we'll talk to you soon.